I don't know if you guys know this, but Bruce Lee was actually the first JavaScript programmer. And he was really good, so the hashtag for this talk is Be Like Bruce. This talk is titled Static Types Are Overrated, the Dynamic Duo, Loose Types and Object Extension. Just a little bit about me. I'm currently on the Creative Cloud team with Adobe. Before that, I've done a lot of other JavaScript application jobs, big applications, not little tiny ones. I've got a book coming out called Programming JavaScript Applications, and that's going to be available really soon. And I've got a book signing later. So the first question is, what are static types? And I think most of you who come from different programming languages already know this. But static types means that you define the type of your variable before you hit the runtime. And sometimes this is done automatically, but usually you'll have type annotations, which means you'll type something like int, and that's the type of that variable, and it can't change. So dynamic types means that your variables can change type during the program flow. So for instance, you can have a function that'll take a variable and you don't know what type of variable is coming into that function. So there's a lot of benefits of static types. They're really good. And we're going to discuss a few of those. But first, we're going to talk about what most people think that static types are good for, and that's for finding and catching errors. Static types are good because it's kind of like a puzzle, a jigsaw puzzle. You get a certain shape, and if that variable doesn't fit that shape, it just doesn't work, and the compiler is going to give you an error. So a lot of people think that the main benefit of catching of static types is to catch type errors. I think that that benefit is largely overrated. We're going to go into that. So I've heard a lot of people talking, there's a lot of discussion on the internet that JavaScript is ill-suited for large applications because it doesn't do that kind of type checking. But the reality is that a lot of big companies are already building a lot of big applications in JavaScript, and that trend is only growing. So are all those people crazy? I don't think so. That warm, cozy feeling, it's like a Linus blanket, right? You think that your program is going to work, but you have no idea. Type correctness does not guarantee program correctness. I want you guys to say this with me. Type correctness does not guarantee program correctness. That was weak. One more time. Type correctness does not guarantee program correctness. So tweet it. I'll wait for you. Remember the hashtag, Be Like Bruce. The first step is fully admitting that the code you write is riddled with errors. John Carmack said that after using about 5 different static analysis tools and still finding all kinds of errors. The point is, you should be doing automated unit testing for in any language, no matter what, whether it does static type analysis or not. And besides that, JavaScript's tools are really underrated. JavaScript has a large variety of really great tools for all kinds of analysis. For instance, JSHint. How many of you people are using JSHint or JSLint or something like that? There should be a lot more hands up. All you people that didn't raise your hands, go and Google right now. So another thing is Turn.js, which integrates into lots of different editors. How many of you are using Turn? Almost no hands. Wow. Look into that. Google that. There are Turn plugins for just about everything, from Vin to Sublime Text, and so there's a lot of ways to get the benefits of Turn. It does auto-completion, function argument hints, it does type inference. You can find where definitions are. You can do analysis-aided refactoring, all the kinds of things that you're used to in a static type IDE. Turn provides some of that for JavaScript. But still, even with all those tools, if you've never seen your program run, you have no idea whether or not it's going to work. In a statically typed language, you'll at least know whether or not some undefined variable is going to make it crash, but you're not going to know whether or not it does what it's supposed to do. So you need some runtime debugging tools to make it really effective. And JavaScript has that in spades. It's got TraceGL, which it records every single function call. It's like an oscilloscope for code. So you can actually watch your functions being called as they're being called. Just a quick show of hands. How many people are using this? Almost nobody. I don't see any hands. Go look it up right now. The address is right here, trace.gl. If you're a JavaScript programmer, you need to have it. Here's a screenshot of what it looks like. This main big window at the top here, that's actually the function, the function call stack. So you can see, well, it's not the stack, but it's the function call log. So you can see which functions were called in which order. That screen at the bottom, you can actually hover over the variables. This shows you which parts of the code have executed and which parts haven't. You can actually hover over the variable names, and it shows you the value of those variables at that particular call. And you can click on the functions and see the asynchronous functions. You'll click on it, and it shows you even the delay between when the function was defined and when it was called for the first time, which is great. There's another tool called Theseus for Adobe Brackets. Adobe Brackets is a pretty cool editor that has lots of inline features that link to your runtime environment. How many people have used brackets? A lot more hands. Good, good. We're getting somewhere now. How many have used Theseus? Fewer hands. Give it a try. It's pretty cool. It does the same kind of thing, only it's integrated right into your IDE. So you can see like how many times a function was called, when it was called, what the value of the variables are, right inside your IDE. And this is kind of what that looks like. As you can see, like there's some grayed out areas. That means that function has not been called. And but that part that sets up the event listener actually has run, so that part, that outside, is white. And you can see the counts of how many calls on the left side there. See 1 call, 0 calls. And then there's the Chrome developer tools. I should see every hand in this room go up. Yeah, that's better. It's a little bit better. So how many people have used the heap profiling tools? A few fewer. How many people have used the Dominators view? Like 3 hands. Check it out. So the Dominators view, it's really great because it helps you see like if there are lingering objects that should be getting collected that are not yet getting collected. The Dominators view shows you the parent object that's still hanging on to the reference for that object. So the point of all this is that static analysis doesn't replace the need to know what your program is doing while it's running. What you really need to do is a lot of testing, hopefully automated testing. So one way to do that effectively is to test at the module level. Keep your modules really small, the Surface API really small, really clear, and then it becomes a lot easier to test all of the functionality. You want to test, if you export some API for a module, you want to test all of that Surface API and make sure that everything behaves as you expect it to behave. And I don't mean like check the types. I mean pass in values that you expect your program to actually see, but don't remember like null and undefined and zero and stuff like that that might get coerced in a way that would be ugly, right? So the holy grail is to aim for 100% code coverage. How many people have ever had 100% code coverage? Like half a dozen? One way to do that is to write your unit tests first, which is actually a really great exercise because if you're doing that, that means that you have a really good grasp of code requirements. How many people have not had good enough requirements when they start coding to do this? A whole lot of hands. Well, if you write your tests first, you'll have a really good understanding of which code requirements you need to know, which questions to ask the product manager. You know, I don't know how many people have gone like halfway into the development and they have to go back to the product manager and say, okay, what happens when we encounter this situation? The product manager goes, I didn't even think about it. I have no idea, right? This is a really great way to answer those questions before you get to that part of the project. And at that point, you might be rewriting code that you've already written. So never write code that you haven't written a test for. So if you're doing this all your tests up front thing, that means that every line of code that you write is there to satisfy some test requirement. And if you do that, you will get 100% code coverage. So another part of testing is you have to make sure that all of those modules are actually going to work together properly. So that's what integration tests are for. So any well-maintained JavaScript project, and I would argue that any well-maintained project has gone through all kinds of testing before you ever run it, before you ever push it into production. So you'll have composed from simple modules, you'll have it linted, you'll have your code peer reviewed. GitHub's pull request is a really great way to do that. And you'll have run your integration tests. And by the time you do all of that, if you're testing properly, there will be very, very few type errors left in your program. So the whole benefit of reducing type errors is almost nullified if you're following a process like this. So I know there's somebody out there in the corner somewhere going, well, why should I do all of that if I can just let the compiler do it for me? Can we tell them the answer? So the true benefits of static analysis, the main one for me is that it reduces cognitive load. I don't know how many of you have to write documentation. You write your documentation, you write a whole bunch of stuff, and then you go back in a few months later and you go, I don't remember what type that variable is, or I don't remember what that thing is for. So type annotations are a really great way to reduce cognitive load because as you're typing, as you're calling that function, your IDE is pulling up these hints that say, I'm expecting a variable named whatever, and this is the type that it's supposed to be. But you can get all of that with JavaScript. There's, how many of you are using JSDoc? Not enough, not enough. So JSDoc is a commenting style that allows you to do type annotations where you want them, where and when you want them. And that's a really great thing, and it's supported by like Google Closure Compiler, and you can actually make Google Closure Compiler stop and give you warnings based on type errors. WebStorm's inline hints are powered by these JS doc annotations. And there's a plugin for Sublime Text called Doc Blocker. And Sublime Text has Turn integrated. So the combination of Doc Blocker and Turn gives you really good hinting in Sublime Text. And Google Closure Compiler, they've got a lot of really great documentation on how to write JS doc kind of their way. And they've got some great like type expressions that allow you to document all kinds of things that you can do in JavaScript that you can't do in languages like Java. So more on jigsaw puzzles, that every piece has its designated place. That little 1x1 square pixel quote you saw earlier, that has a major implication. That means that there is an easy analysis of required memory allocation. That means that you won't have the garbage collector sneaking up on you and grinding your program to a halt. So you do have some control over that in JavaScript. I know there's Asm.js, but a lot of that is compiled from another language, but there are other techniques you can use. For example, you can code like a pirate. Kill your crew before you sail. Colt McCandless gave this really great talk called The Joys of Static Memory JavaScript. If you haven't seen it, you must see it. You must watch this talk. In fact, you guys should all tweet this right now. Kill your crew before you sail. Colt McCandless. So the disadvantages of static types. There's a really good reason that a lot of languages allow for dynamic types. And the first and foremost for me is that when your language doesn't allow dynamic types, you end up reinventing dynamic features in the language, only you don't do it very well. So there's this Greenspun's 10th rule. Have you heard of Greenspun's 10th rule? There are a whole bunch of examples of this out in the wild. Basically, it states that any sufficiently complicated C or Fortran program, and I would add any sufficiently complicated program at all, has an ad hoc, informally specified, bug-ridden, slow implementation of half of Common Lisp. I don't know if it necessarily has to be Common Lisp, but definitely a lot of programs end up implementing some kind of an eval to get more dynamic features. Things of that nature. Like in C, how many C programs are there in here? A few, a few. How many of you have used the void star hack? Just about every C programmer that just raised their hand. So the way that works is you take a function like this that just works on ints, and you try to lift it so that it'll work on other things, like floats and longs and things like that. So you end up creating some kind of enum and list your types. And then you do something like this, right? You pass in the type as a parameter. How many of you have done that? Almost none. Good. There's one guy was kind of sheepishly, yeah, I think I've done that. Ta-da! Now you've got dynamic types. And it was really easy. You only had to define the function 3 times, right? So there is a better implementation. There's a better way of doing that. especially if you're enumerating over a large list of things, and that's to like pass in your function that actually does the type processing. And that's better than passing the type in and then switching on it, but only a little bit better. So in JavaScript, the same function looks like this. And this automatically works with all of the numbers, but I'm kind of cheating because there's only one number type in JavaScript right now. Hopefully we'll get some more, but right now we don't have any more. But it also works on strings. Woohoo! We got free parametric polymorphism. The only problem is if you do that with 1, you'll get 11 instead of 2. Oops. So I know it could be better, but we're going somewhere with this. Trust me. Generic functions work the same on any type that you pass in. So the body of the function doesn't change based on whether or not you pass in a number or a string or an array or an object. The body of the function behaves exactly the same. And there's a lot of JavaScript built-ins that actually are generic. For example, the index of method on the string, it works for all kinds of things. You can build a contains with it. That same thing will work on arrays. And you can do things like, how many of you are using the map and for each and filter and stuff like that? Good, good, good. So that's kind of those are kind of the foundation of functional programming. How many people know that you can use map on a string? It works, it works. So reality check, if it's not standard, probably shouldn't go extending the built-ins. That still holds true. I know there's some people that think it doesn't because you can exclude it from being enumerated over, but so the way that this stuff works is you have a few different function types that all kind of play really well together. We're going into a little bit of functional programming basics here. So the first type, you take a function that takes some kind of a list and you pass in a function that operates on the items in that list, and it returns an array, or returns the list, the same type of list, with those things transformed. So things like map and filter can do this sort of thing. And then there's transform functions, and these will take that simple type or that type that you pass in, that one element, right, and transform it in some way, like add a number to it or multiply it by 2 or whatever, and then return the result of that. And then there are filters, and those return booleans. So you'll pass in a single element, and you'll get true or false, like, does this thing belong to the new collection or not? And then there's reduction, and it's things like reduce, right? You get an element, and you get a list, and it accumulates some value, like a sum or something like that. So lifting. Lifting is the process of taking a type-specific function and making it type generic. For example, we're going to use sum, right? If you try this with objects, it's not going to work. You're going to get not a number. But there's a way to get a lifted version of this. If you use dot value of and sum with that, then it'll work. But first, you have to define that value of function. So here we've got an item factory that'll crank out objects that are compatible with this new lifted function. So then you can sum your objects, and it works. And of course, it still works with the numbers. So the way that you do that is you identify requirements, and you make sure that the objects that you pass in match those requirements. So in this case, we changed the requirements to it must have a value of function. Notice there's no crazy template syntax, there's no void star hack, there's no type noise. You didn't have to define the same thing 3 different times. So generics in C++ and Java kind of melt my brain because they use things like the template syntax like this. So the template, you pull in some constructible and turn the thing that you're passing in into a new instance. And then you instantiate this template, and it turns into a different function for every single type. And that's kind of what happens under the covers, but you're exposed to the mechanics of it in C and Java. And that's kind of awkward, I think. So I think that poor readability is every bit as dangerous as ambiguous types. So there's a couple of styles of type polymorphism that you need to know about. The first is the ad hoc polymorphism, where you define a different way of operating on the same kinds of things. So each different type gets its own implementation. And then there's parametric polymorphism, which is that thing I was talking about where there's only one function body to worry about. And in JavaScript, it's really easy to make sure that you only have to worry about a single function body. So there's some other cool features of dynamic types. The one that I love the best is dynamic object extension, which means you can take like any kind of object, like a hamburger, right? Add another topping to it, and that just works, right? So object and prototype extensibility is really important in JavaScript. Like, for instance, you can turn anything into an event emitter, and I went into this a little bit in last year's talk. If you haven't watched it, check out Classical Inheritance is Obsolete. Just Google for it. So this extensibility thing is how the jQuery plugins work. Everything just kind of tacks itself onto the jQuery prototype. So to recap, JavaScript's analysis tools are actually a lot better than you thought, and you really need to investigate those if you're doing anything serious in JavaScript. And the ability to easily skip type annotations makes generic programming easier. And dynamic object extension is the heart and soul of prototypal OO. So, leave you with this quote from Bruce and take any questions that you might have.
Hello. I come from a C++ world.
Can't hear.
I come from a C++ world.
Yeah.
Pretty new to the JavaScript world. And we do have, I'm working with this application, and we do have objects which are passed to functions. And okay, it doesn't have a type, but it has a duck type. And we kind of rely on certain attributes being there. When they're not, a program goes, bleh.
Yeah.
So how does one deal with the fact that although it may not be a particular type, it has to have certain duck types, certain attributes present?
Yeah, and that's the kind of thing that we do in JavaScript is you duck type, right? In C, if you do that, it can actually prevent your, you can make it so that it'll prevent your object from, or your program from even compiling, right? Depending on how you write it. In JavaScript, it doesn't prevent it from running. So you can pass something in, and if it doesn't suit it, it's going to throw an error. But that's a pretty good thing, right?
What I find is that we don't pass the right thing, and then at runtime it dies. I guess it's basically a matter of not testing sufficiently. But
yeah,
I'd like to be able to look at the routine and say, this routine needs an object that has these 3 things in the object. And there's nothing there that tells me that without going back to the history of the object. So
sure, you can actually do type annotation in JavaScript that'll kind of give you a hint about what kinds of objects you have to pass in, right? And if you're doing that, you get some of the benefits of that static analysis while you're writing your program. but it's still you still need to understand the behavior of the program at runtime. So you have to run it, you have to analyze how it actually behaves.